Morning everyone. Today we are going to learn about the cross iteration method. Here in this video we will learn about what are linear equations, why we use iterative method, importance of Gauss Seidal, Jacobi versus Gauss Seidal, and numerical solutions. It is faster convergence, fasterness, convergence, immediate values, updates, efficient computing, and real-world applications. It solves variable one at a time using the most recent computed value immediately in subsequent calculations, leading to a faster convergence than methods only using only old value. Compared to the Jacobi iteration, Gauss Seidel converges fast because each variable update instantly incorporates the last results, reducing the number of iterations needed. So here in our Gauss Seidel method, it converges fast because we will take the updated value. In our previous method, that is Jacobi method, we are taking the values like first 000, then the values came out, we will take in another one. But in Gauss Seidel method, we will take the updated value. Suppose if we take 0 for x1, what value we get for x1 by putting the value 0, we will put that value in finding x2, not do the same like Jacobi. So it is converges faster. Its formula its formula is that if there are a matrix, then we will apply this formula like x equals to b1 minus a12 minus a13 z, or y equals to b2 minus a21 x minus a23 z, and b3 minus a31 x minus a32 y, and divide all these by diagonal values. Now, what are the key insights? Updated values are used immediately in subsequent calculation, enabling faster convergence. Like if we put 0 here for here in y and z, and we will get the updated value of x, then we will put that value here and put z equals to 0. And when we get x and z values, when we get y value and x value, then we put both updated value in the z. So it converges fast as we are putting the updated values. Uh, the system of linear equations, the problem statement given to us to solve is that linear equations, there are three linear equations given to us. We have to solve them. That is 10y2 6, 10xy plus 2z equals to 6 minus x plus 11y minus z equals to 25. 2x minus y plus 10z equals to minus 1. By on the basis of these formula, we will put the values here like b1 is 6, and then y uh, minus y. Here you can see that we have to put minus a1 to y. So we will put minus a1 to y, and then z. So here we put the value of z. Y, x, y, z, we will assume the values of x, y, z as an initial guess later. Firstly, we will put the values of these matrix into the formula similarly as we have learned here. Now we will take first initial guess like x0, x0 is equals to 0, y0 equals to 0, and z0 equals to 0. In our first iteration, we will get the value of x equals to 0.6, y equals to 2.327, and z equals to minus 0.987. These values are calculated by using the updated values. As I have taught you before, that here we get the updated value as x, then we put these values here, and z equals to 0 as the initial previous guess, and x value is updated value that is used. Now we will find the y, we will find the z. Here we will get the updated value of y and updated value of x. Then we put both in here and it is fully updated value. In the next, we will use the updated values. And in further, we will got our convergence and get our results. The value converts rapidly toward the solution. X close to 1, y equals to 2, and z equals to minus 1. Each iteration uses updated values, immediately accelerating the convergence as I have told you. And these are the graphs how the value converges. X is here, and that's a y, and that's z. The final answer, as we have got by the Gauss Seidal convergence solution, x equals to 2, x equals to 1, y equals to 2, and z equals to minus 1. The value converges very quickly, as we have seen. In just three iterations, we will get our desired values. Because the variable are used immediately and subsequent calculations. This immediate update strategy is what makes Gauss Seidal faster than Jacobi method. Here, algorithm will start input the system of linear equations and rearrange each equation to isolate the variable on the left side. Now, in second step, we will take the initial values, initial guess, and calculate the x using the latest value of x. Use new value to calculate y. Uh, use new value for calculating y. We will use new value of x, and for calculating z, we will use new value of x and y both. Here in step 3, we will check the convergence criteria. If not converge, repeated iterations. Once the converge, print final solution. Now, there is a Python program for the Gauss Seidel method. Here, initial guess is taken. Now we'll start a for loop for I in range of 10, and we will put the formulas we have calculated here and print the iteration and print the results, which iteration is that, and print the results. And now, also here will be, this is only for the Gauss Seidel. For checking the convergence, we will use our different formula. Okay, now the convergence output, as we have seen, we have got our output x equals to 1, y equals to 2, and z equals to minus 1. Each iteration defines approximation using updated values immediately. And practical applications. This is used in engineering analysis for structural systems, scientific computing simulations, and numerical methods in physics and large-scale matrix computation in data science. And that's all about the Gauss-Seidel method. For learn it or understand it, you all can solve questions, and we will solve the numericals. If there are any doubts, you can ask in the comment section. I will be solving that in our next video. Thank you. Have a nice day. Like, share, subscribe.